Hi everyone. A particle is initially at the origin and moving to the right at 5 centimeters per second. It accelerates with time according to the given acceleration function. So we need to answer the following questions without using a calculator. So we want to find the velocity of the particle and then sketch the graph. So the velocity of the function is actually the antiderivative of a of t, dt. So all we need to do is write down our acceleration function 4 minus 2t dt and take the antiderivative of that. And so that's going to equal 4t minus t squared plus c. Now, we have to find the c, but we're given that's initially at the origin and moving to the right at 5. That means that v of 0 equals 5. So we're going to set this v of t to 5 equals and plug in zeros for these t's. That gives you c equals 5. So your final velocity function is equal to 4t minus t squared plus 5. Now, we're going to sketch the graph for that, and I'll go ahead and write the function here again. Equals, we can't do this with the calculator, so let's write this out, plus 5. And we just need to know v of 0, v of 1, v of 2, v of 3, v of 4, v of 5, and v of 6. So v of 0 we already know is just 5. So we're here at our initial starting. It's 0 seconds. So now v of 1 is just going to be 4 minus 1 plus 5, and that's going to be 8. So we'll just go kind of close to 8. So I'll put 8 about here. I'm just estimating. And v of 2 is going to be 8 minus 4 plus 5. And that's going to be 9. So for this, I'll just put this a little closer to my 10. V of 3 is going to be 12 minus 9 plus 5. And so that's going back down to 8. V of 4 is going to be 16 minus 16 plus 5, which equals 5. So we're back down to 5. And, 5 goes here. And for 5, we get 20 minus 25 plus 5. That equals 0. So at 5, we're at 0. And 6, we're going to get 24 minus 36 plus 5. And that's going to give us negative 7, I believe. So this would be 29 minus 36, so that's negative 7. So here we're just going to go down a little bit on 6 and put it about here. So if you sketch it, looks like this. Something that's our domain from 0 to 6 seconds. So this is your t, and this is your v of t, and your t is in seconds. All right. The next thing we have to do is find the displacement of the particle. Well, your displacement is s of t, which is actually the antiderivative of v of t, dt. So for the displacement, we're going from 0 to 6. So what I want to do is write my s of t. I know my v of t, and I'll write the v of t was 4t minus t squared plus 5. So if I take the antiderivative of that, that's going to be 4t squared divided by 2 minus t cubed divided by 3, plus 5t. And then we're going to evaluate this from 0 to 6 over that interval. Well, this simplifies as 2t squared minus t cubed divided by 3 plus 5t. And this is from over the interval 0 to 6. So you plug in your 6, and you're going to get 2 times 6 squared is just 36 minus 216 divided by 3 plus 5 times 6. Now, when you subtract the 0 part, when you plug in 0 and all that, that's just going to give you 0. So the only thing we have to do is this part, and this is just going to give you 72 minus 72 plus 15, and that's going to equal, where did we get 15 from? What did I do? 3. So this should be 5 times 6, and I did 3. So this should be 30, not 15. Silly me. So this is going to be 30, what do we do in centimeters? That's your total displacement of the particle. Now, for total distance traveled, we're going to do, we already know that v of t equals 4t minus t squared plus 5. And what we want to do is set this to 0, since we can't use a calculator and use our sign diagram. So I'm going to rewrite this as 5 plus 4t minus t squared equals 0, and factor it. And when you factor, you're going to get 5 minus t, and then we're going to get 1 plus t equals 0. Let's see if this works. So we get 5 minus 1 gives me my 4. So that works out. So we get t equals 5, call that t1. t2 equals negative 1. We don't want a time where t is negative. So we're going to disregard this one and just use this as our sign diagram. So we want to go from 0 to 6, and we want to see what's going on about t1 equals 5. So I just plug in 0 into this equation here. If you plug in 0, you're going to get 5 times 1, which is a positive number. So this is positive. You want to plug in, say, 5.5. Let me erase this now. We got this part. get something in the middle. This should be negative because it's linear. These are linear terms. So plug in 5.5. This is going to be negative, and this part will be positive. So that makes a negative. So that means when we do our S of t, we're just going to do S of, that's going to be the antiderivative or the integral of Vt dt. And we're going to go from 0 to 5. And then since it has minus, we're going to subtract and go from 5 to 6 of Vt dt. So when you do that, you're going to get, we already did this part. So this part's just going to be 2t squared minus t cubed divided by 3 plus 5t. And we're going from 0 to 5 minus, let's do this again, 2t squared minus t cubed divided by 3 plus 5t, and we're going from 5 over the interval 5 to 6. When you plug in your 5, you're going to get 2 times 50 minus 125 divided by 3 plus 25. When you plug in 0, that's just going to give you 0. So all of this right here equals 250 divided by 3. So that's that. Now minus, now we plug in 6, and that's going to give us 2 times 36 minus 216 divided by 3 plus 30. And then we got to subtract this. Well, when you plug in 5 into this, you're going to get this number. So it's be minus 250 divided by 3. Now this whole thing equals negative 160 divided by 3. So what we end up having is, and I'm going to move it up here, 250 divided by 3. 2 negatives make a positive 160 divided by 3. And that's going to give you 410 divided by 3 centimeters is your total distance traveled. And that's it. Thank you. Have a nice day. Bye-bye.